NASA's James Webb Space Telescope has made an unexpected cosmic discovery in the Serpens Nebula, revealing stunningly aligned stellar jets. Previously seen as blurry blobs, Webb's advanced imaging has brought these protostellar outflows into sharp focus, uncovering a unique moment in the region's history that provides crucial insights into star formation. Using its near-infrared camera, NIRCam, Webb captured detailed images of young stars and their outflows in the northern part of the nebula. These outflows, typically varied in orientation, are astonishingly aligned in this region, like sleet pouring down in a storm. This rare alignment suggests a historical record of star birth processes that astronomers have long theorized but never directly observed. Principal investigator Klaus Pontoppidan from NASA's Jet Propulsion Laboratory explains that as clouds collapse to form stars, they spin in the same direction, leading to aligned outflows. The jets, appearing as bright, clumpy streaks of red due to molecular hydrogen and carbon monoxide, indicate shock waves from the jets colliding with surrounding gas and dust. Lead author Joel Green of the Space Telescope Science Institute notes that this area of the Serpens Nebula comes into clear view only with Webb, allowing astronomers to catch these extremely young stars and their previously invisible outflows. This discovery highlights Webb's exceptional resolution and sensitivity in near-infrared wavelengths, providing unprecedented insights into the early stages of star formation. Webb's findings not only shed light on how stars are born, but also demonstrate its potential to reveal more cosmic phenomena, making it an invaluable tool for future astronomical research. A major setback occurred on Monday when U.S. Spacewalk 90 at the International Space Station was abruptly canceled due to a water leak in an astronaut's spacesuit, halting essential maintenance and scientific tasks. NASA astronaut Tracy C. Dyson experienced a water leak in the service and cooling umbilical unit of her spacesuit, just as she and fellow astronaut Mike Barrett were about to embark on a critical spacewalk. At 8:46 a.m. EDT, both astronauts had switched their suits to battery power and opened the hatch of the space station's Quest airlock when the issue was discovered. The primary objective of this mission was to remove a faulty electronics box, known as a radio frequency group, from a communications antenna on the starboard truss. Additionally, Dyson and Barrett planned to collect samples to study how microorganisms survive and reproduce on the exterior of the orbiting lab. Dyson, wearing a suit with red stripes, and Barrett, in an unmarked suit, were prepared for what would have been Dyson's fourth and Barrett's third spacewalk. This would have marked the 271st spacewalk dedicated to the assembly, maintenance, and upgrade of the space station. Following the detection of the water leak, the crew collaborated with ground controllers to repressurize the airlock's crew lock section before safely returning to the station's equipment lock. NASA has assured that all necessary precautions were taken to ensure the astronauts' safety. This incident underscores the inherent risks of space exploration and the critical importance of equipment reliability. As NASA continues to investigate the cause of the malfunction, efforts to reschedule the spacewalk are already underway, ensuring that the essential tasks can be completed in future missions. NASA's Perseverance rover has captured an image of a mysterious white rock on Mars. This rock, unlike anything seen before on the Martian surface, could provide valuable insights into the planet's ancient history. Discovered in the Jezero crater, the rock measures 45 centimeters in width and 35 centimeters in height. Its origins are unknown, but scientists speculate it may have been transported by an ancient river from another part of Mars or emerged through erosion from underground. Perseverance, which landed on Mars in 2021, continues to explore the planet's surface, seeking signs of past life and collecting samples. This intriguing find adds to the growing list of discoveries that help us understand Mars's geological history and potential for past habitability. Astronomers worldwide are eagerly anticipating a nova explosion visible to the naked eye this year. This event, set to occur in the Corona Borealis constellation, happens approximately every 80 years and is a subject of great interest for both professional and amateur astronomers. T Coronae Borealis, known as T Carb, is a binary star system located about 3,000 light-years away from Earth. In this system, consisting of a white dwarf and a red giant, as the white dwarf accretes hydrogen from the red giant, it accumulates significant pressure and heat, eventually leading to a thermonuclear explosion. Dr. Rebecca Hounsell suggests that this event will inspire young people to engage with astronomy and may uncover new scientists. The last observed T Carb nova was in 1946. A similar explosion is anticipated this year, potentially occurring by September 2024. Corona Borealis is known as a horseshoe-shaped asterism located west of the Hercules constellation. The explosion will be visible to the naked eye for approximately a week. Amateur astronomers will share this event instantly through social media and email alerts. NASA and other space agencies will utilize various telescopes and satellites to observe this rare event. The data collected will play a crucial role in understanding the structure and dynamics of recurrent stellar explosions. Astrophysicist Dr. Koji Mukai from NASA Goddard commented, "Recurrent novae are unpredictable and contradictory. Just when you think they're not following any specific pattern, they do. And just when you start trusting their repetition, they completely diverge. We'll see how TCRB behaves." Astronomers worldwide are eagerly anticipating a nova explosion visible to the naked eye this year. This event, set to occur in the Corona Borealis constellation, happens approximately every 80 years and is a subject of great interest for both professional and amateur astronomers. T Coronae Borealis, known as T Carb, is a binary star system located about 3,000 light-years away from Earth. In this system, consisting of a white dwarf and a red giant, as the white dwarf accretes hydrogen from the red giant, it accumulates significant pressure and heat, eventually leading to a thermonuclear explosion. Dr. Rebecca Hounsell suggests that this event will inspire young people to engage with astronomy and may uncover new scientists. The last observed T Carb nova was in 1946. A similar explosion is anticipated this year, potentially occurring by September 2024. Corona Borealis is known as a horseshoe-shaped asterism located west of the Hercules constellation. The explosion will be visible to the naked eye for approximately a week. Amateur astronomers will share this event instantly through social media and email alerts. NASA and other space agencies will utilize various telescopes and satellites to observe this rare event. The data collected will play a crucial role in understanding the structure and dynamics of recurrent stellar explosions. Astrophysicist Dr. Koji Mukai from NASA Goddard commented, "Recurrent novae are unpredictable and contradictory. Just when you think they're not following any specific pattern, they do. And just when you start trusting their repetition, they completely diverge. We'll see how TCRB behaves." Researchers at EPFL have used computational tools to produce the world's thinnest metal wire from copper and carbon atoms. These structures, known as 1D materials, are considered among the most intriguing products of nanotechnology, with potential applications spanning from microelectronics to biosensors due to their electrical, magnetic, and optical properties. In their study, scientists scanned over 780,000 crystal structures to identify candidates for 1D materials. Among the top 14 selected candidates is a metallic wire named CuC2, composed of carbon and copper atoms, noted as the thinnest stable metallic nanowire at 0 Kelvin. Researchers plan to collaborate on experimental synthesis of such materials and continue computational studies to understand their performance in real-world applications. This research could significantly contribute to the future advancement of nanotechnology. scientists have developed a new class of materials called glassy gels, which combine the hardness of glassy polymers with the elasticity of gels. These innovative materials contain over 50% liquid, enhancing both their stretchability and adhesive properties. Glassy gels are produced by mixing polymer precursors with ionic liquids and curing them with ultraviolet light, resulting in a simple production process suitable for various high-performance applications, including electronics and medical devices. Due to their high liquid content, glassy gels are more efficient conductors of electricity compared to traditional hard polymers. They also exhibit notable adhesive properties. Professor Michael Dickey from North Carolina State University and his team found that glassy gels can stretch up to 5 times their original length without breaking and can return to their original shape when heated. This unique combination of properties indicates a wide range of potential industrial applications. The research team discovered that glassy gels can be made with various polymers and ionic liquids, although not all polymer classes are suitable. Tests have shown that these materials, despite containing 50 to 60% liquid, do not evaporate or dry out. The straightforward production process and broad application potential make glassy gels a promising material for future technological advancements. The researchers are open to collaborations to explore the diverse applications of these innovative materials. This breakthrough heralds exciting developments in the fields of engineering and materials science. Scientists have developed a groundbreaking iridium-free catalyst for water electrolysis, paving the way for sustainable, large-scale green hydrogen production. Hydrogen, as a clean energy carrier, holds significant potential for decarbonizing society. However, most hydrogen is currently produced from methane, a fossil fuel, through a process that emits substantial carbon dioxide. Developing scalable methods for green hydrogen production is therefore crucial. Water electrolysis, powered by renewable and clean electricity, offers a promising path to generate green hydrogen. This process requires cathode and anode catalysts to accelerate the reactions of water splitting and recombination into hydrogen and oxygen. Among various electrolysis technologies, the proton exchange membrane, PM, stands out due to its high efficiency and rapid production rates. However, PEM electrolysis traditionally relies on rare and expensive elements like platinum and iridium. A team of researchers, including ICFO scientists Ranit Ram, Dr. Lucia, Dr. Anku Guha, and others, led by Professor Dr. F. Pelayo Garcia de Arcer, has made a significant breakthrough by developing a novel iridium-free catalyst that achieves stability under industrial conditions. This innovative catalyst design involves incorporating water and its fragments into the catalyst structure, enhancing both activity and stability in harsh acidic environments. The research, published in Science, highlights the collaborative efforts of multiple institutions, including the Institute of Chemical Research of Catalonia, ICIQ, the Catalan Institute of Science and Technology, ICN2, French National Center for Scientific Research, CNRS, Diamond Light Source, and the Institute of Advanced Materials, INAM. This new catalyst, based on abundant and inexpensive cobalt, offers a viable alternative to iridium-based catalysts, making it a promising candidate for industrial applications. Professor Garcia de Arcer explains, conventional catalyst design typically focuses on changing the composition or structure of the materials. Here, we took a different approach by involving the ingredients of the reaction in the catalyst's structure, enabling stable operation at high current densities. Despite this significant achievement, the team continues to explore other materials like manganese and nickel to further improve the catalyst's performance. Ram shares his motivation, saying, "Advancing renewable energies is crucial for combating climate change, and our research is a step in the right direction." This breakthrough in green hydrogen production represents an exciting development in material science and renewable energy, with the potential to significantly impact various industries and contribute to a sustainable future. Swedish scientists have produced the world's first living computer made from human brain tissue. This innovative device exchanges information much like a traditional computer chip and has the potential to address global energy crises. Composed of 16 clusters of brain cells grown in a lab, the living computer communicates through neurons that send and receive signals, mimicking the function of a conventional computer chip. What sets this technology apart is its remarkably low energy consumption. While the human brain uses 10 to 20 watts of energy, modern computers consume 21 megawatts to perform the same tasks, over 1,000 times more energy than the human brain. These mini brains, about 0.5 mm in diameter and consisting of 10,000 live neurons, are trained with doses of dopamine. When they perform tasks correctly, they receive a chemical reward. Scientists stimulate specific regions by exposing them to light to mimic dopamine release. The organoids are surrounded by 8 electrodes to measure activity. This breakthrough blurs the lines between biology and technology, opening up new possibilities in computing and neuroscience. Despite numerous ethical considerations, the living computer marks a significant milestone in technology, challenging our perceptions of what is possible and raising profound questions about the future of artificial intelligence and humanity's relationship with technology. Elon Musk has announced that he will ban Apple devices in his companies following Apple's integration of ChatGPT with Siri. This new feature, unveiled at Apple's WWDC event, sparked a wave of backlash due to concerns over user data being shared with OpenAI. In a post on X, Musk declared, "Apple's use of ChatGPT is an unacceptable security breach. Apple devices will be banned in my companies, and visitors will have to leave their devices at the entrance." The feud between Elon Musk and OpenAI has reignited. Musk claims that OpenAI has strayed from its original mission and become profit-driven under Microsoft's influence. OpenAI counters that Musk tried to merge the company with Tesla, leading to his withdrawal of support. These dramatic developments have sent shockwaves through the AI and tech worlds. The Norwegian government has signed an agreement to stockpile 30,000 tons of grain in preparation for unexpected emergencies. According to a statement from the Norwegian Ministry of Foreign Affairs, this agreement was signed by Agriculture and Food Minister Geir Pollestad and 4 private companies. The grain will be stored in the facilities of these companies, but will remain the property of the Norwegian government. This decision aims to ensure the country is prepared for potential crises. Speaking to Norway's NRK radio, Minister Pollestad mentioned that additional stockpile agreements will be signed to increase reserves through 2029. Norway had closed its grain storage facilities in 2003, deeming them no longer necessary. However, with this new agreement, the country is returning to grain stockpiling. Researchers have announced that a simple blood test using artificial intelligence, AI, could detect Parkinson's disease before symptoms appear. Parkinson's disease is a neurodegenerative condition affecting approximately 10 million people worldwide, especially the elderly. It causes tremors, involuntary movements, muscle stiffness, and slow motion, alongside cognitive and mental health disorders that worsen over time. Scientists using machine learning to identify 8 biomarkers in blood tests claim a 100% accuracy in diagnosis. Michael Bartel, lead author of the study from the University Medical Center Göttingen in Germany, stated, "By identifying 8 proteins in the blood, we can potentially detect Parkinson's patients several years before symptoms arise. This means drug treatments could potentially be administered at an earlier stage, potentially slowing down disease progression or even preventing its onset." The study also analyzed blood samples from 72 patients with rapid eye movement behavior disorder, IRBD, linked to neurodegenerative disorders. Researchers followed these patients for a decade to predict whether they would develop Parkinson's. The test correctly identified 79% of these patients as having a similar profile to those with Parkinson's disease. Kevin Mills, senior author from University College London, emphasized, "We are pioneering the use of the latest technology to discover new and better biomarkers for Parkinson's disease, aiming to transform them into a test usable in any major NHS laboratory. And we hope this could be achievable within 2 years with adequate funding." Forecasts predicting Europe's hottest summer ever have raised concerns among weather experts and forecasters. Extreme heat is already being felt early and intensely in countries like Greece, Cyprus, Turkey, and Italy. In some regions, temperatures have soared more than 10 degrees above seasonal averages, posing potentially lethal consequences. Cities across Europe are taking various measures to cope with scorching temperatures. In France, organizers of the Paris Olympics are considering the risk of extreme heat for athlete safety, while Spain is developing new maps for more accurate weather forecasts. Meteorologists note they are under the influence of consecutive months of record-breaking temperatures worldwide over the past 11 months. Sea surface temperatures in the North Atlantic have also reached their highest levels in the past 40 years. Tamsin Green, a meteorologist from Weather and Radar, points out the highly variable nature of weather conditions across Europe due to numerous influencing factors, making long-term predictions challenging. However, she anticipates above-average temperatures during June, July, and August. Green emphasizes that climate change is a significant factor in Europe experiencing increasingly hotter summers. According to data from the World Meteorological Organization, WMO, and the European Union's Copernicus Climate Agency, Europe has been warming at twice the global average rate over the past 30 years. In conclusion, Green believes 2024 will likely be another record-breaking year, and stresses that the trend of increasing global temperatures cannot be ignored. Meteorological officials have reported that extreme heat in Karachi, Pakistan, has resulted in the deaths of 14 people over the past 24 hours. Temperatures in some parts of the country have soared to 53 degrees Celsius, with Karachi experiencing temperatures over 45 degrees and a humidity level of 76%. The deceased were between the ages of 25 and 45. In response to these record-breaking temperatures, officials have advised residents to stay indoors unless absolutely necessary, stay hydrated, and avoid travel. The Pakistan Meteorological Department, PMD, has warned that hot winds from the northwest could push temperatures even higher in Karachi today. These severe temperatures have significantly impacted daily life and raised health concerns. Authorities emphasize the importance of protecting vulnerable populations, such as the elderly and children, from heat stroke. According to the report from the European Union's Copernicus Climate Change Service, Saharan dust is significantly impacting air quality in the eastern Mediterranean, including Turkey and Greece. Earlier this week, a new Saharan dust wave reached southeastern Europe and the eastern Mediterranean. Increased PM10 particle concentrations are expected in these regions on June 13-14. The report highlights a significant drop in air quality in southern and southwestern regions of Turkey. Dust clouds from North Africa in April had turned parts of southern Greece orange and reduced visibility in many Turkish cities. The Saharan dust is expected to raise PM10 concentrations in Bulgaria, Cyprus, and Greece, surpassing the EU's defined air quality limit of 50 micrograms AM3 over a 24-hour period, indicating a serious decline in air quality. Authorities in Bulgaria, Greece, and Cyprus are closely monitoring the dust wave. Vasilis Amaridis from the Athens Observatory notes the potential health impacts of the recent dust transport, emphasizing public awareness. Elena Hristova from NIMH in Bulgaria aims to educate the public by monitoring the intensity and effects of these events. Silas Michaelides from the Eratosthenes Excellence Center in Cyprus stresses the importance of international cooperation and scientific research in addressing this issue. According to a recent study conducted by the National Institute of Geophysics and Volcanology, INGV, Venice, a lagoon city, faces significant underwater threats due to rising tidal levels and land subsidence. Even the current flood barrier system protecting the city may prove inadequate against continuous inundation and sea level rise. Researchers have determined that tidal levels are increasing by approximately half a centimeter annually, potentially leading to permanent submersion of certain areas in the city by 2150. Particularly, it is estimated that some sections of Venice's renowned square, St. Mark's Square, could be submerged under 70 centimeters of water. Additionally, the western part of the city is among the areas frequently affected by floods. INGV researchers warn that this rise in sea levels could accelerate coastal erosion and have significant environmental and socio-economic impacts. Applicants will be able to receive payments ranging from $10,000 to $30,000 to purchase homes in mountain towns in Italy's Tuscany region. Authorities in Tuscany have announced that they will offer payments of between 10,000 and 30,000 euros to people who move to depopulated mountain towns. Italy's rural towns and villages have been experiencing a population crisis for some time. Small regional communities face abandoned homes and stagnant economies as local residents migrate to cities for better job opportunities. Authorities in Tuscany preferred to offer payment in exchange for residence. Under the new Residency in the Mountains 2024 program, applicants will be given between 10,000 and 30,000 euros to buy a house in the Tuscan countryside. However, the house must be in a mountain town in Tuscany with a population of less than 5,000. Additionally, the financial contribution cannot exceed 50% of the property purchase and renovation costs. Stefania Siccardi, vice president of the Tuscany region, stated that the Tuscan mountains have uniquely beautiful areas with villages waiting to be rediscovered, but they are suffering from depopulation. Therefore, deciding to live in one of these municipalities can be both a challenge and an opportunity for young people, a chance for a new life choice. It is important to note that there are strict conditions on who can apply for the grant. Applicants must be Italian citizens or citizens of another European Union (EU) member state. Non-EU citizens with a residence permit of less than 10 years can also apply. Additionally, applicants must have registered residence in an Italian town or city, but not necessarily in a mountain town as categorized by the Italian National Institute of Statistics. Applications can be made using the online form on the Tuscan region website and must be submitted by 13 local time on 27th of July.